Hey everyone. So this is another streaming of a long time I'm doing in YouTube. Hey everyone. So hope my session is working fine. Okay. Okay. So I'm planning to start this series for Snowflake, especially Snowflake database, and I'm basically I worked on Snowflake for various projects in my past company in my previous projects also. Um, but always when you start for the projects, you always jump into the actual code itself, right? Building the data model or your data engineering pipeline, and then you start working with the business, and that's how we usually do, right? For any tools. So I thought, okay, let's break down the entire Snowflake database in the multiple chunks as a 30 days challenge, so that we could uh, understand the product at very well and in depth, to explore each product in more detail, right? So if you take Snowflake, it has a variety of components and flavors along with that. It is not quite easy to grab all the things in a very short time. But I believe if we have this kind of challenges put ourselves, that would help us to motivate ourselves to move forward with, and we understand the product very well better rather than jump into that project itself. So that's the reason I thought, okay, let's have this kind of streaming session. It'd be useful for me and useful for someone like me to want to utilize uh, this kind of session to uh, you know uh, for a, for a, it's like a learn together concept, right? So that is the whole idea for this session. So probably I mean, if you see this video, um, later you can you throw your comments of if you want to know about particular topic after on the day 2 or day 3 or day 4, so on, and we'll take the topic and we'll explore it, and we'll see how depth we can go to the particular component in Snowflake. The whole idea is let's try to you know become expert at least. I don't say it's an expert because in 30 days we can't be expert, but at least we'll try to uh, get uh, the the projects and get to find out how the Snowflake looks like, and what are key components. And if we give for an interview, I think this 30-day challenge would help at least 5%, 10% for your interview. So that is the whole idea. So for the day one, I come up with I collected few materials from the forum and then Snowflake documentation, and I prepared the presentation for it. So I'm gonna explain each component which I explored on the day one. So instead of jumping directly into the Snowflake UI and start coding, I thought let's understand the Snowflake itself, the core concept, the core Snowflake architecture itself. So so this is the one which I'm sharing at the moment, the screen. So this is a starting point. If you are new to Snowflake, uh, you know, if you understand what exactly the Snowflake it is, and what is the key component, how you can log into Snowflake. There's a bunch of way you can log in. probably you could use using web interface or using backend CLI. When I say CLI, it's a NoSQL, or you can use third-party connector um, um, like Matillion or other kind of partner vendor product, or you can use Python connector, JDBC. So there is various option you can connect Snowflake overall, but in this video, I thought, okay, in this session, let's stick with at least the basics and core concept of the Snowflake itself. So, yeah, this is the overall high-level documentation page. If you click on every tab here, it will redirect to the whole in-depth of the particular component. So, but I already prepared uh, I grabbed few key areas, which is core function for Snowflake. I grabbed that information and put into the PPT. Um, so yeah, let's start with a few points which I collected. So this is something I got from the internet forum. So Snowflake is developed internally in 2012 and officially launched in 2014. There's probably um, everyone might aware about it. So, and Snowflake is a data warehouse tool, data warehouse platform where it is built especially only for cloud. So you can't run in on-premise. So, um, I read the Snowflake forum and Snowflake documentation, and what I understood is Snowflake from scratch, they focused on building the platform only for the cloud environment. So that's why you don't have any opportunity to download the software, run in local or something on-premise, nothing. There's no such concept as of now in Snowflake. So whatever it is going to be in cloud. So that is the whole uh, idea. Um, and the key concept in architecture. So Snowflake is a data platform as a self-managed service. Uh, as I mentioned, this is pure cloud-based SaaS model, software as a service model, and so we have to, you have to pay what you're using. That is the whole idea, and you the other thing is you don't want to, you know, it minimize the whole overall database administration perspective is, but still we do have a DBA, but not extensively like in traditional platform like Oracle, Exadata, MySQL, those kind of stuff not required. And the interesting part is the Snowflake architecture, right? The Snowflake architecture is a hybrid. Uh, this is the keyword. Hybrid of traditional shared disk and share nothing database architecture. So when I see this terminology, I was really confused initially. So if you take any platform or any data or any product, it should be either under shared disk architecture. What is a shared disk architecture, right? Shared disk architecture is nothing but I have a diagram also. This also I collected from the internet. So shared disk architecture is you have one persistent data storage, which common for your entire nodes. So if you have a n number of compute nodes in your cluster, all the cluster node will be connected or read and write from the same disk storage. That is called shared disk architecture. That is how most of the traditional database system softwares will work. So how you can just we can just simulate the process how the shared disk architecture will fit on Snowflake. Um, and what is and when they say hybrid, they also mentioned about shared nothing architecture, right? So this is the shared nothing architecture. So you have a individual computer. the cluster node, and each individual cluster node will talk to uh, each individual storage. So basically, it's an independent, isolated storage for each node. That is called shared nothing architecture. So, but Snowflake uh, combinedly called us hybrid architecture because they design in such a way to use shared disk architecture and also shared nothing architecture. So, where exactly they're using shared disk architecture, right? So, when you read the SQL, when you write select star from SQL, let's assume select star from table, that this record, this SQL, this query has to fetch the data from somewhere, right? Uh, Forget about the computation process, but at least the persistent data storage, right? When I say persistent data storage, the data won't change frequently. Foreign, when it's when you do the execution of the query, right? So in those situations, shared disk architecture will come in place. So basically, read the data, write the data from the common data storage. So they are using common data storage using AWS S3, or GCS bucket, or Azure Blob. So there is this is how they have a you know they have a shared disk architecture for shared disk storage for reading and writing the data permanently. But when exactly the shared nothing architecture? So what is the problem? Just keep with the shared disk architecture. Think about you have the huge query, performance query that has to do some performance. Uh, if you keep all the data in a common storage or shared disk storage, then the I/O between the your compute node, the cluster node, and the storage cost will be more. So obviously, we'll end up with a performance degrade, right? So that is the biggest drawback of shared disk architecture when you do the execution, query execution, um, actually, right? So the shared nothing architecture, it is like when you do perform select sum of data group by some group by some column, right? So what does it do? This Snowflake pass this query to multiple cluster node, uh, cluster one, cluster two, and each cluster which will have own storage, S1, S2. So when it is execute the query, it has to store the data uh, for that session perspective. I mean, temporarily, it has to do the calculation and store the data somewhere in the storage itself. For that purpose, it's using their own share nothing own storage on top of the node which is computing, right? So if let's assume if you don't keep the storage, then every time these cluster nodes has to you know read from the common storage, which will the network throughput from the storage and the compute the cluster node will be a biggest problem. But if you keep the data, the cache data within the storage uh, same cluster node, then it'll be easy for the machine for to compute as quickly it can, and then push the data back uh, to the client interface, right? So that's the whole architecture. That's what my understanding. So that's why they call this hybrid shared disk plus shared Nothing. So, I mean, I, I, I I hope I just, explained at least the key concept of the key architecture behind what exactly they call this hybrid. Snowflake is hybrid architecture. So nothing but they just segregated the uh, two different architecture on two different places because the shared networking architectures are also called MPP, massive parallel processing. So that is this is the key. This is the architecture is mostly used in many of the databases like Teradata, Oracle, etc. MPP is a master behind the scene. It's a I mean the parallel processing concept. So they want to leverage the parallel processing process. At the same time, they don't want to keep the data in each individual node as separate storage. That will be obvious. That will be again it's a headache uh, for the users or a headache for the Snowflake to bring all the data from different storage and then uh, and then combine the state data and show to user. Instead, they keep the persist data completely on the shared disk storage and the query execution data this sits on the compute node storage. So that is the major difference between shared disk architecture and shared nothing architecture. Then and Snowflake they combine called hybrid architecture. Um, right. So another thing is this is the this is the diagram, architecture diagram. Uh, they have put in the Snowflake documentation. Uh, Probably they might feel this is it's straightforward, but honestly, from my perspective, it is they have to put little more direction about each individual layer. But whatever I explained so far, that is what is happening behind the scene of each individual the flow which they are given here. So um, the Snowflake which is running on each individual nodes, when you it's a multi-cluster uh, warehouse basically. So for each individual client or each individual person, they are running multiple clusters and multiple in each cluster they have thousands of hundreds of virtual private network and the particular VPC which has these three different layers like database storage which I mentioned about the where it is exactly the data has been persist, right? That is the database storage and query processing. So when you when you connect the UI or when you start writing the select SQL, so it is behind the scene. It is called this query processing, and they call they map they mapping those query processing into the virtual warehouse. So you have to make sure to create a virtual warehouse that will discuss later in the when we move on to the next level of the user interface where we can see virtual arrows about those things. So that is the second layer of the I would say three it's like three-tier architecture. So one is database storage and the query processing where exactly the query will be executed. And the cloud service is nothing but the Snowflake connection uh, interface to the the underlying architecture, right? So we may need some uh, protocol to connect to the Snowflake cluster. That's called authorization access control, and that is where it comes under the infrastructure manager and like the users roles, security. All these parts will be a part of the cloud services. So this is the typical diagram they have mentioned uh, in the Snowflake documentation. All right. Okay. So and this is another level of you know uh, detail abbreviation about what exactly Snowflake do, right? So it can get the data from OLTP, enterprise application, third party applications like OLTP and say Oracle ERP, SAP. You just can stream in the data, enterprise application, any application, as long as it has the backend data. I hope all the enterprise applications should have it. And then third party API, those things, and then weblog, IoT. So these are the various data sources you can think of, and then we can use regular ETL load process or streaming, or if your data sitting somewhere and if you want to do the streaming using Kafka, yes, you can do that. And and you can think like Snowflake, not just like data warehouse. You can also think like a data lake, because it's also handling unstructured data. So we can we can deal Snowflake as a data lake, and obviously you can use the data engineering, all things, and the data science data application. So pretty much whatever the related to the data, uh, we can do all the things in Snowflake. So yeah, so that is something, and of course they are providing all the connected to the all most of the applications, so we can connect um, our Snowflake database from all the reporting tools available in the market today, because it has a JDBC connection also. So yeah, so that is something I want to. This is also again I got it from the some internet article page. Um, and yeah, this is architecture and provisioning. Yes, uh, it's like when we execute the query, when we execute the query, uh, it based on the your warehouse selection, warehouse size. We'll talk about warehouse size and selection probably in upcoming videos, because that is something like the resource allocation of of your cluster of or your warehouse. The Snowflake hierarchy, the storage architecture will decide whether whether it will whether it need to stay in the memory, or if the data is not fit in the memory and then it goes to SSD, is another solid state drive disk, right? And then it will move to the persistent other storage for long time, for longer purpose. Yeah, this is just for a reference purpose. I just kept it. Um, you know how the Snowflake architecture, the storage is working, and yeah, this is something the shared nothing architecture which I talked about, which I talked it. And then right now, Snowflake you can be we can be hosted in any of these platform in AWS, GCP, and Azure. Um, but I think I don't see any challenges on this area so far. I personally, for my personal testing purpose, I tested these three hosting platform. I mean, I, I I think there was some limitation on GCP that we can talk if required in if he specifically wants to talk about GCP. But apart from that, I don't see any challenges in hosting the Snowflake on this platform. And then, so what are the ways we can connect um, the Snowflake? So I think the beginning of the session, the video I talked about the different access methods. So one is called web user interface, like in your browser, we can connect the Snowflake, and another option is the SnowSQL. So I think I installed it, SnowSQL. Let me show you. We can just type NoSQL. So this is something we need to install the NoSQL client to connect. Uh, so So if you install properly, then you can see this output. So this is another way, and the third party client service like Python connector, JDBC, all those stuff. So this is all about login. Let me. I think I kept this link. Um, see. What else we can do in web interface? Like we can write a SQL, run this Python, Snowpark Python code. You can monitor your query performance and history, and you can create a worksheet and share the worksheet with your teammates or outside of your Snowflake account, external account. Basically, let's say, right, maybe I'm created one Excel sheet or worksheet. I if I want to share that worksheet with you guys, right? If you have account in Snowflake, then obviously you can also view the what I did or view the data what I developed or what I stored, right? So that is something cool about the Snowflake um, interface. And then you can visualize the worksheet with the chart. These and all, I think we're gonna take a look when we move on further. But uh, but this is what they have been provided at the moment. And then another interesting part component called Streamlit. Um, that is separate topic. But recently, I think last year, Snowflake acquired a Streamlit company. Now they integrated Streamlit. It's like a visualization uh, tool framework. It, it's built on top of Python. So you can write your Python and Snowflake combination and visualize the data very quickly and host the data, host the application and share the results. That is something cool about Streamlit. And then develop your native apps and share the native apps is something I mentioned. Manage cost, create manage users, all this stuff we can uh, we can we can do it in the UI. So right, so this is something very um, very cool about the thing. And And the thing is, yes, supported cloud regions. So I just took only for US at the moment. So these are the on given platform, on given cloud. So what are the regions available at the moment? You can host your Snowflake account. So before you started accessing or creating the account, uh, probably you can choose whichever is preferred based on your location or based on cost that we have to decide accordingly based on our needs. And then the snow site, that is something the same in UI which I uh, just mentioned. So uh, so another thing is if we want Snowflake community is very good actually. In case if you when you stuck somewhere on account creation or any kind of issues, you can log in and you can create a account on this community platform, and then you can submit your question. Some folks will respond um, for the question for the questions you're raising. So they have very good community platform. And yeah, that is something I want to cover it also. And another thing is, let me probably I can um, show. So this is my account I created in Snowflake. So I have my username and password. So once you created the account, so let me go to the Snowflake account creation. Yeah, if you go here, yeah, you have to provide your name, company name, email. Uh, I mean, this is not really meant to be a company name because I created using my Gmail ID, so it is not really required to only use with the you can go with your personal Gmail or whatever it is, email you have. And then once you created it, you have to provide your credit card, but it pay on usage, 30 days, after 30 days free trial. If you run any query, then it will charge. Apart from that, but cost wise, I don't see any huge mess up so far. I don't see any problem at all. So far, I mean, I'm running my uh, Snowflake account more than a year now. I don't face any issue at the moment. Probably, I don't know in future. So yeah, so once you created everything, in your email, you will get activation email link. The activation email link, you will get a unique account name. Before that, that showed that, right? The same account name. So once you get the account activated, and this is how the landing page. This is the new user interface which they provided, but previously they had a classic console. Um, they have a console like this. So this is the classic, the old Snowflake interface. So it has pretty much like same thing, all the all the component, all the things, but the new interface has more options or more user friendly than the old interface, like or classic console as per their naming convention perspective. So yeah, this is the landing page. So you can see your the by default your account name will pop up here. What's the account identifier? And then you can check the profile and then client download. The download is nothing but the other way of want to you don't want to use, let's say you don't want to use user interface. You want to connect these Snowflake from Snowflake, like you're from your command prompt or from your terminals. Then this is another option to access the Snowflake account. The latest release also they have added the Visual Studio extension. So from Visual Studio extension also you can access your Snowflake account directly. That is also another coolest part. Um, yeah. So and you if you see it has various uh, tab like projects, uh, data products, monitoring. So it's a single source of truth where you can play around with that and we can get all the details uh, in this page itself. So you can create a database, you can create a data warehouse, or you can store data lake, or if you want to create a virtual warehouse, or you want to create a task, or if you want to create a Snowpark code, if you want to create a Streamlit application, or if you want to write a machine learning code, or if you want to write LLM integration, Cortex, whatever it is, this is the place. Uh, this is also one of the place. You can write everything from backend also, but this is also another important place that generally the developers will go here and do all the things. So along with you guys, I'm really exciting to learn each individual component in depth and see probably in case if I miss any particular topic, or if you want to have anything specifically, if you want me to talk, just put put me in the comment section, or just let me know in the LinkedIn. I can try to get the details and we'll learn together accordingly. So yeah, so this is just an as a day one. So I just want to stick with the basic introduction of Snowflake. The main key part is it's a shared disk architecture, it's hybrid architecture. So it's a combine of both shared disk and shared nothing architecture. And other thing is I forgot to mention Snowflake is a columnar storage format. So whatever we are writing or inserting the data, Behind the scene, it will store as a columnar data set. We will talk about columnar in detail in next video, but for now, it is not like a traditional database. Traditional database, it's like sitting on row level data, but Snowflake is storing the data based on the column. So that is the biggest difference in terms of architecture. And this is a three-tier architecture. It consists of uh, data storage, query processing, and the cloud services. And it is a MPP. It's a massive, you know, parallel processing cluster compute nodes. And it has can hosted in AWS, GCP, and Azure. And we'll come up with the two different interface, new interface in classic console. And other thing is not only user interface you can access, you can connect from SnowSQL, the CLI terminal, or you can connect from the third-party application. So, and I'm pretty sure this series we're going to talk about not only the particular component, we'll take each, we'll take some projects on each individual component and we'll deep dive on particular area and we'll discuss further. Yeah, we'll see in next, maybe day two challenge. I'm not sure whether it's tomorrow or whenever when I'm doing streaming, but it's going to be a day two. So let's see. Thank you.